I want to go through some equations now using our inverse trigonometric functions. So they're going to be similar to what we were doing before, but I think it's a good idea to see how these equations work. Let's start off here with question 16, and all we want to do is solve for inverse sine x equals to inverse cosine x. Now, because these two things are different, the first thing I need to do is change one of them into either inverse sine or change that into inverse cosine. Okay, I can't work with them if they're two different trigonometric functions. This is sine and this is cosine. So can you think of any way that I can change this inverse cosine into inverse sine? Are there any properties that we've learned in the previous modules? Yeah, there is this property where we know that inverse sine x plus inverse cosine x equals to pi on 2. Yeah, so we're using this property. I can say that inverse cosine x equals to pi on 2 minus inverse sine x. Yeah, can you see how I've changed that to that step there? And now I just want to move this inverse sine to the other side. So I have 2 times that equals to pi on 2. Divide the 2 down, so equals to pi on 4. And now I can just switch the input and the output, make this into sine, and I just need to find what sine pi on 4 equals to. So that's sine 45 degrees, and our exact values, which tell us that's 1 on square root 2. So solving for this, x equals to 1 on square root 2. So this is what you needed to know for this was the property here of your inverse trigonometric functions. And this comes up quite often. So I would definitely make an effort to memorize that. So you can see it's quite similar to when we do trigonometric functions, but we'll be using slightly different properties. Okay, let's have a look at question 17 now. So here we want to solve inverse tangent x plus inverse tangent 2 equals to inverse tan of 7. Now, this, I don't expect you to know how to do that just by looking at it, so this is why I'm teaching you the process, so when you see a similar question, you'll be able to. The first thing we want to do is let this equal to alpha and let that equal to beta, okay? So this equals to alpha, that equals to beta. So I can say that alpha plus beta equals to inverse tangent of 7. Now, I want to get rid of this inverse tan, and how I can do that is by making the tangent of both sides. So what I mean is I can make it into tangent alpha plus beta equals to 7, okay? And this is our first equation. Yeah? Now we need our second equation. So essentially it ends up being almost a simultaneous equation. The second thing we can do is we know that tan alpha equals x, tan beta equals to 2. Now, we also know that when we expand tan alpha plus beta by using this information here, we can make it into, so that just becomes x, that becomes 2, and you have 1 minus 2 times x. So you have 1 minus 2x. So can you see how by doing that, I've made my second equation. And since both of them has tan alpha plus beta, yeah, I can therefore say that this must equal to that because they both equal to tan alpha plus beta. So from 1 and 2, I know that this fraction equals to 7. And now it's just simple algebra, multiply that to the other side, expand that, so that becomes 7 minus 14x. We can move that 14x to that side, which becomes 15x. 2 to this side, 7 minus 2 is 5. Divide 15 across, so x equals to 1 on 3. So you can see here what we do when we have a question like this is we want to essentially make a simultaneous equation. So by making that into alpha and beta and making the tangent of both sides, I worked out that tangent alpha plus beta equals to 7. Now I want to find another value for tangent alpha plus beta, And what we did here is we used the expansion of that and then these values here. And by expanding it, I was able to make this algebraic equation here to work out the answer. So when you see something plus something, something minus something, which is slightly different from question 16, where we only had one value on either side of the equal sign, what you need to do here is to think about your simultaneous equations. And one of them is going to be using the expansion as we've done there.